Have you ever wished your scripts could be, a little bit smarter? Like they could actually look at a situation and make a decision all on their own? Well, today, that's exactly what we're going to do. We're giving our scripts a brain using conditional logic and Bash. So, can a script really think for itself? Well, in a way, yeah. By using conditional logic, we're giving our scripts the power to look at a condition and choose the right path to take. This is what turns a boring list of commands into a truly dynamic tool, making your automation faster, smarter, and just so much more powerful.
All right, here's our game plan. We'll start with the big idea of making decisions. Then we'll build up from the basic if statement. After that, we'll add an else path for more options, handle multiple conditions with elif, see how this all works with text and files, and wrap it all up with 3 golden rules you absolutely have to know. Okay, let's kick things off with the core concept. Scripts that can actually make decisions. This is where we move beyond a script that just does what it's told to one that can react and adapt to what's happening.
So, at its heart, if-else is basically the brain of your script. It asks a simple true or false question and then decides what to do based on the answer. You can think of it like a fork in the road for your code. Should it go left or should it go right? If-else is what lets the script figure that out. To build that brain, we've got to start with the most basic piece. And that brings us right to our second section, the basic if statement. This is the foundation for everything else we're going to do.
Okay, let's take a look at our very first example here. We start by setting a variable age to 20. Simple enough. Then comes the if statement. Now, the condition itself goes inside these square brackets. We use $age to get the value of our variable, and GG is the operator that means greater than or equal to. So what this line is really asking is 20 greater than or equal to 18? The answer is yes, so the condition is true. That means the script runs the command right after then, and it prints you are an adult. Now, if the age was, say, 17, that test would be false, and the script would just skip that echo command entirely. So let's just quickly break that structure down. The if with the square brackets, that's your test. The then keyword is like the green light. It says, okay, that test was true, so let's do this next part. Then you have your action, what you actually want to do. And finally, every single if block has to end with phi, which, hey, is just if spelled backward. A neat little trick to help you remember. That basic if is great, but it only really handles one outcome. The real magic happens when your script also knows what to do when the condition is false. And for that, we need to add an else path. And this visual just perfectly shows the jump we're making. A basic if is a one-way street. It does something if the condition is true, and that's it. But when you add an else, you create 2 totally separate paths, one for true and one for false. This is the moment your script goes from just following a list to actually making a choice. Let's see it in action. Here, we've set marks to 35. The if statement checks if that value is greater than or equal to 40. Well, 35 is not greater than or equal to 40, right? So this test is false. And because that test failed, the script completely skips the then block. It will not echo pass. Instead, it jumps straight down to the else block and runs that code, printing fail. See? We now have a plan for both outcomes. So the most important thing to get here is this. The else keyword is your plan B. It's the otherwise in your script's logic. It creates that second branch that only gets used if that first if test fails. This gives your script total coverage for any possible answer. 2 paths are good, but let's be real. The world is often more complicated than that. What if you need to check for 3 or 4 or even more possibilities? For that, we need to be able to handle multiple conditions. The classic grading example. This is perfect for showing how we can chain multiple checks together. The script always starts at the top. Our score is 75. So first it asks, is 75 greater than or equal to 90? Nope, that's false. So it moves on to the next check, the elif, which is really just a short way of saying else if. Is 75 greater than or equal to 60? Yes, that's true. So the script immediately runs echo grade B, and then it stops. It found a true condition, so it exits the whole if, elif, else block without even looking at the final else. So elif is your tool for creating a decision-making ladder. The script just works its way down, checking each rung. As soon as it finds one that's true, it does its thing and then jumps off the ladder completely. And that final else, that's your safety net at the bottom, catching anything that didn't match any of the previous conditions. So far, we've only been playing with numbers, but your script's decision-making powers go way beyond that. You can also compare text, and this one's incredibly useful, you can check if files exist on your system.
It is definitely not just about numbers. Here, we're comparing text, or what we call strings in programming. We set the variable name to admin. The if statement then checks if the value inside $name is a perfect match for the string admin. It is, so the condition is true and we get access granted. This is super useful for things like checking user input or verifying settings in a config file.
And this is a real game changer for automation. Look at that operator, F. This special test checks if the path we gave it actually exists and is a regular file. So this script is checking to see if /etc/passw is really there. Why is this so important? Because it stops your scripts from crashing. Instead of failing when a file is missing, you can check first. If it's not there, your script can create a new one or at least print a helpful error message. It just makes your automation so much more robust. Now, to make all these number comparisons, you're going to need this essential toolkit. These are the operators you'll be using inside those square brackets. You've got EQ for equal, NE for not equal, GT for greater than, and so on. Definitely get familiar with these. They are the heart and soul of your numerical tests in Bash. We have covered a lot of ground, but to make sure this all actually works and to save you from countless headaches down the road, we need to finish up with the 3 most important syntax rules. Let's just call them the 3 golden rules.
Please, please commit these to memory. Number 1, and this is the most common mistake I see, you absolutely must have spaces inside the square brackets. It's space condition space, not condition. The shell needs those spaces to work. 2, every if and elif line has to be followed by then. And 3, every if structure must be closed with a phi. If you follow these 3 rules, your scripts are going to be so much more reliable and error-free.
And there you have it. You now have the fundamental tools to give your scripts a brain, letting them adapt, react, and make intelligent choices. The possibilities are really endless, from a simple backup script that checks if a folder exists to a complex deployment tool that acts differently based on the server environment. Which leaves us with just one final thought. Your scripts can now make decisions. So, what are you going to automate first?